Dear learners, a peculiar property of magnetic materials is in our today's discussion. It is diamagnetism. There are some materials which are repelled by a magnet. This property is called diamagnetism, and the materials are called diamagnetic materials. Bismuth is an example. Two orbiting electrons of an atom of a diamagnetic substance are shown in figure 1 and 2. One is revolving clockwise and the second one is doing so anti-clockwise. Two orbiting electrons of an atom of a diamagnetic substance are shown in figure 1 and 2. One is revolving clockwise and the other is doing so anti-clockwise. Clockwise revolution makes an anti-clockwise current and anti-clockwise revolution makes a clockwise current. Both the electrons are revolving with the same angular speed omega naught in two circles of the same radius, that is equal radius r. We assume that the electrons are revolving in the plane of our page. The first one constitutes a magnetic dipole moment mu along the upward normal to the page, and the second one constitutes a magnetic dipole moment mu along the downward normal to the page. So the total dipole moment in the atom is 0. Two Coulomb forces of equal magnitudes Fc and Fc on both the electrons act as centripetal forces. The magnitude of these centripetal forces are Fc equal to mv square by r. V equal to r omega. Therefore, m r omega naught square divided by r, as electron is revolving with an angular speed omega naught. Therefore, Fc equal to m r omega naught square. When a magnetic field B is applied vertically downward into the page, two magnetic forces Fb and Fb act on the electron. Two magnetic forces Fb are of the same magnitude, Fb equal to EVB, but Fb is towards the center for the first electron and it is away from the center for the second electron. It is away from the center for the second electron. That is, first one is along the direction of Coulomb force Fc, centripetal force, and the second one opposite to the Coulomb force, that is opposite to the centripetal force. As a result, the angular velocity and thereby the magnetic dipole moment of the first electron are increased. Then the new dipole moment of the first electron is mu plus delta mu. The angular momentum of the second electron decreases. Second electron, as the net force on the electron decreases due to the opposite magnetic field, so the dipole moment of the second electron decreases, and the new magnetic dipole moment of the second electron is minus mu minus delta mu. Then the total dipole moment is equal to mu plus delta mu plus mu plus, that is minus delta mu, and the total dipole moment becomes 2 delta mu. This total dipole moment, magnetic dipole moment of the atom is vertically upward. We remember the magnetic moment of the first electron was vertically upward, and the magnetic moment of the second electron was vertically downward. That is, one was mu and another was minus mu. And the resultant magnetic dipole moment of the atom is twice delta mu, which is vertically upward. It is opposite to the applied field, as the field was applied vertically downward. Look at the figure. A sample of magnetic material is kept near a magnet. When the induced magnetic moment is directed towards the applied field, then we see the opposite pole is created at the near end and similar pole at the far end. Whereas in the second figure, you see, if the magnetic moment created induced magnetic moment is opposite to the applied field, then similar pole will be created at the near end and opposite pole will be created at the far end, resulting a repulsion. Thus, the diamagnetic property of a material may be visualized from the creation of an opposite magnetic dipole moment under the action of the applied field. Thanks.